All right, welcome to the November Geophysical Society of Alaska monthly luncheon. And our speaker today is Bretwood Higman. And Hig received his PhD at the University of Washington, where he studied the geologic records of tsunamis. He now lives in his hometown of Seldovia, Alaska, where he splits time between his family, the study of geologic and climate hazards, trail building, and science education, amongst other things. He has helped study several sites where there is a history of or potential for landslide-generated tsunamis, including Ton Fjord and Icy Bay, Greywink Glacier or Greywink Lake near Homer, and Barry Arm and Prince William Sound. All right, we're excited, and take it away, Hig.
Thanks, Matt. I'll go ahead and share my screen. Let's see here. Yeah, so thank you, everyone. I'm hoping this will be a good presentation to kind of stimulate a little discussion. Really feel free to raise your hand or even jump in and start asking questions right in the middle of the presentation too. As I put this together, I started not liking the title I came up with, but I didn't come up with a better title. I could do something really boring like this: preliminary observations based on an inventory of Alaska landslides and instabilities. But hopefully it'll be entertaining, whatever this talk might be titled. I'm going to go through a little bit of my own history and how I got into this subject, and explain what I'm trying to do with this landslide inventory, which will be kind of the main focus of my talk. And then I'll give you sort of a tour of some of the things that I've come across looking across Alaska. And then I might continue that into actually just go ahead and open my GIS, and I'm not sure exactly how long. Actually, I'm going to get my clock going in the background here because I don't want to just totally ramble on forever here. But let's see here. There we go. So anyway, I might go on and talk about, show in my GIS some of this, because there's other ways we can look at it there. So my background, my dissertation work was mostly on the 2004 Indian Ocean tsunami, and I'm in that. My work there was as a sedimentologist, a stratigrapher, and I kind of developed a way of trying to read tsunami deposits. And so I developed a model and applied that to observed deposits of sand on shore left by the 2004 tsunami and other tsunamis around the world. And one of the things that really got me, I found really interesting in this work, was that these deposits seem to record a lot of information about the tsunami, including information about the period of the tsunami, so how long it took to inundate on shore. And this is one of the first things that kind of got me thinking about landslide-generated tsunamis. It's hard to study tsunamis without becoming familiar with the 1958 tsunami in Lituya Bay. It's kind of the most famous example of this. And it's famous in part for being so gigantic and destructive. But another thing that's unusual about it relative to many of the tsunamis I had studied is a very, very short period. So I thought, well, this should really have a very distinct record. We should be able to see something of this in the deposits. But I never had a chance to actually go and study the Lituya Bay tsunami or the after effects of that, and kind of moved on to other things for a while. This is Ton Fjord in Icy Bay, and in 2015 there was a very large landslide there. So it was somewhere on the order of 50-60 million cubic meters. Came off the mountain, went onto the edge of the glacier, and ran down the length of the fjord. And when it did this, it generated a large tsunami. And these are run-ups in meters. So it had the highest run-up was about 193 meters. So I heard about this later in 2015 and kind of just jumped in to participate in the effort that was mounted to study this event and learn what we could from it. And I did get my chance there to see some of the effects of this kind of an event. So the landslide source is in the background here. This piece of the mountain failed, went into the fjord, and actually this is actually a block from the landslide here. I think that's Anya Dufresne standing on it. The landslide actually went into the fjord to depths of 80, 90 meters before it had enough momentum and it carried up to the other side and left these blocks here. And it had some really interesting and actually quite thick deposits. There are places where we didn't get anywhere close to the bottom of the deposit in this proximal area, where it left deposits that were many meters thick. And they were so different from what I saw in tectonic tsunamis that a lot of the models and stuff I developed were really almost non-applicable. For the purpose of this talk, though, the reason that this is important is that this was a case where here's one of the tectonic tsunami deposits. Totally different story, basically. But there are a couple things that really kind of redirected my my work that as a result of this. And one was that I just met a lot of really interesting people who work on landslides. Martin Geertsma is in this photo, but it was a whole, I just happen to have a good photo of him here, but a whole bunch of people are doing really interesting work on these large landslides. And so I began to learn a little bit about possible relationships between climate change and this sort of landslide and some of the other related topics. And it was also just a chance to see the destructive power of these tsunamis generated by these landslides. And this one, I kind of like this photo because there's this brown bear down at the bottom here for scale. The tsunami as it swept down the fjord really just completely resculpted the entire coastline, flattened these huge forests. And I think in a lot of ways, we've kind of just been lucky is the reason we haven't seen a really catastrophic event with these landslides happening around Alaska. So this is a satellite photo of that ton landslide. So it failed here, went down, mostly went into the fjord. A little burp of it went out onto the glacier here. These are these blocks, mallard hummock sort of things that actually where the landslide went through the fjord and up onto the other side. This photo is actually one of the things that strikes me about it is it's somewhat similar to this photo taken after the 1967 Gruen landslide. So the landslide came from here, went into the lake, a little burp of it went out onto the glacier like this, and it generated a large tsunami that flowed down through the outwash plain down from Gruen Lake. It left giant icebergs. You can still walk around and find the holes where these icebergs sat, and the current went around them and deposited sediment. So and this happens to be really close to where I live. This is right across from Homer. It's a big piece of the Homer View and a popular tourist destination. And so while in 1967, people only infrequently went up here, now it's a really popular tourist destination. Sometimes there are hundreds of people in the valley within the area of the 1967 tsunami inundation. And so that got me motivated to really start trying to understand these events and understand how we might assess the hazard in a place like Gruen. And it was while I was doing that along with a number of other people, and I won't go into the long story of this, but we stumbled across this instability above Berry Glacier. So this is a satellite photo from 2013 Landsat. So we're zoomed way out here. And that's 2016. There are a few things that change between these two photos. But if you draw your eye to the area here, just west of the B and Berry Glacier, you'll see that the mountain shifts towards the water between these two images. So what we learned is that as Berry Glacier retreated past this bit of slope, it accelerated. It had been shifting for some time, but it accelerated and moved tens of meters per year for a number of years. And it's since in the last few years, starting about 2017, it's slowed down. And it's still deforming, especially, it probably is right now when with the heavy rain in the fall, but it's mostly seems to be have paused anyway in its deformation. But it went through this period of really rapid deformation. So if we just kind of set that instability up next to some of these other big landslides in Alaska, it's much, much larger than these other ones. And I think it's worth looking at these and kind of thinking about what we knew before the event. And so if we look at Lituya Bay, well, in 1900, there was a landslide that generated a tsunami here. And actually, it killed a number of people. It was reported in the newspapers at the time. But that was not widely known when in 1936 this happened again. There was another landslide, generated a tsunami, and actually people died again in that. And that was also actually there's Carl Tape at UAF. I'm sure some of you know him, has done this investigative work and found that there are records of these events that actually made the media and such, but they weren't widely known. In the 1950s, there was a geologist, Miller, who was in the area studying the glacial history. He was really amazed at these trim lines from past tsunamis, which he didn't know they were tsunamis at the time. And he speculated about various things they might have caused this. And he went and he actually cross-sectioned some trees, dated them pretty well. Then he left and he came back in 1958, just after this giant tsunami, landslide and tsunami that has made the place so famous, in which 2 people died on the boat, the Sunmore, as it was trying to flee the bay. So there was a lot of history that was known about this before, but it was never put together into like, okay, maybe we should think about this as a hazard. Grink Lake, I don't think there was anything specifically noted about the instability before it failed. However, there were photos taken in the 50s and in 1964 that clearly show the cracks and the evolution of that slope prior to its failure. In Tanfjord, this landslide started moving in the mid-1990s, and it was actually mapped by geomorphologists and noted as this large landslide. And there was actually quite a bit of science was done in the area, partly because the glacial retreat here was so dramatic. It's one of the most dramatic glacial retreat sites in Alaska. So it was noted, scientifically, but it was never, there's no connection made between that deforming slope and a potential for hazard, And it was a popular tourist destination. Usually it's just kayakers and a few fishermen who go up into this immediate area, but not far away there are year-round lodges, and there are also occasionally cruise ships that come up into the bay, small cruise ships. And so there's no connection made at any point there between this unstable slope and the potential for a tsunami that might pose a hazard to people. Fortunately, no one was there, and actually the way that the tsunami propagated, it didn't impact the onshore facilities in outer icy bay, which we could have probably figured out by modeling it and could have reassured those people if we'd known anything beforehand, but instead we didn't know and we got lucky. So now Barry hasn't failed, but it did go through this episode of really rapid deformation from 2007 to 2017 or so, a little bit more than that. And it was totally missed during that time. There were geologists in the area, even geologists who work on geologic hazards and tsunamis and landslides, who, they weren't looking for that evidence and they didn't see it. And, something where you can actually see a mountain, move when you flip between landslide images, it's hard to get more obvious, geologically speaking, than that. And it's really a place where, there's kind of a limited set of places you might look around in Alaska that kind of have similarities to that are places that where there's this really dramatic glacial retreat, which is associated with some of these landslides. So there's every reason we might have looked at that site, and instead we just stumbled across it. So this sort of thought process made me think, well, maybe it's time that we actually take a look around systematically and just say, what else is out there? And so that's kind of how I started in assembling this inventory that I'll talk about a bit here. Is I was just like, well, are there other obvious things that we're missing? And so I started looking at satellite images at available LiDAR. I also just kind of put out the word that I'm interested in any landslides, any instabilities that people know. And it's been really a productive process. There's a lot going on here. Some of this has actually led to a little bit of actual, research being done, a lot of effort to get there. We're still a lot of it's still in progress. And it's been really eye-opening for me. I really didn't appreciate at all what I was going to find. And I've definitely expanded kind of the scope as I've gone through this, and I'm looking in a lot of places where there's no tsunami component to the hazard. So yeah, part of this, my inspiration here is that hazard. And then part of it is also, as I started looking at this, there were patterns that I saw in here that I didn't understand. And so that's just got me really kind of scratching my head and curious. And I think there's a lot of potential for landslide research in Alaska. And that research might really help not only understand the physical processes better, but also help mitigate this widespread hazard, and in particular, understand what we might be in for as climate change continues. So in order to give some sense of what this inventory is, rather than talking a lot about methodology or anything, I'll just say my methodology is quite haphazard. So if you're concerned there might be biases and such in this data set, absolutely, there are definitely biases. I have tried to look at least to some degree in all the different general areas of Alaska. So if you're noticing the way there's this no big dots down in Southeast Alaska, I've actually looked quite a bit at the mountains down there. And I I know that there's a tremendous amount of landslide activity down there. However, what I'm looking for are specifically these deep-seated either large volume failures or instabilities that could potentially lead to those. And I haven't been able to find them there. And that's partly, just available data. It's partly because things are more heavily vegetated. I think it's probably also that the geology is less favorable to these really large failures. But so anyway, I want to just give you a tour, kind of wander around through some of what I've seen, and hopefully that'll stimulate some questions and discussion. So I think it's good to start with just some landslides here. This is the Amulet landslide. It's south of Matanuska River, the upper Matanuska River. It was pointed out to me by locals who live in the area. And there's beautiful imagery of it. And I apologize for it would be great to have like a little location map for every one of these, but I did so many that I didn't quite get to that point. But you can see the source area really well, that this section of the mountain let loose. This area is definitely permafrost country. You can see rock glaciers and stuff in this area. And then there's this really blocky landslide, and it flowed it was quite mobile, went down into the lowlands. And one of the things I think is really striking about this one is some of these blocks formed these really classic mallards, which I only have a shallow grasp of what all the implications of that, of the semantics of the word mallard are, but they're these conical hills that are left behind by landslides. And one of the things I find really amazing on this one is these mallards that traveled down this piece of slope, and they mowed these ski trails down the slope. In a different image here, you can see these open swaths. So the mallard, here's one mallard at the end of this path here. It's just this conical pile of debris. And you can see it actually mowed its way through alder and spruce forest and left this just beautiful grassy stripe. I really want to go and ski along it now. Here's a couple more in this area. So anyway, I think that's a really interesting aspect of this landslide. This is the one I put in my kind of splash advertisements along a stream called Trail Creek, really remote area north of the Tikchik Mountains in Western Alaska. It may well have been noticed by locals. If they call it Trail Creek, that might be because it's a good path to go for snow machines between villages. But to my knowledge, other than me, I guess the geologists haven't noticed. Again, you can see the source area really well. The landslide let loose here, and then it kind of exploded out in this area. It's an extremely mobile landslide. You can see this kind of radial spreading across the valley. And it's a little harder to pick out because there's some snow on the north-facing slope in this image, but it actually ran up the valley wall on the other side. Completely disrupted the river. That's now this kind of series of ponds through here. This one's probably big enough that if you looked through the seismic record, there's probably some seismic signature from this landslide. One more kind of in that general class here is the Mount Alice landslide. This was actually directly witnessed by locals in Seward. It's right above Seward. And these are photos by Deb Kurtz, National Park Service ranger in the area, or not ranger, I think she's a National Park Service scientist, showing the event just after it happened. And so it ran down the mountain into the forest below. You can kind of get a sense of the source here. It's actually really hard to figure out the source just by comparing before and after images, because it's in this really steep terrain above the glacier. And it's, you know, comparing satellite images, those areas are not terribly well resolved. And so I'll use that as my little transition into landslides that are coming from steep mountainous terrain in southern Alaska and going across glaciers. This is probably one of the best studied type of landslide in Alaska. Jeff Coe, Aaron Bessett-Kierton, Martin Geertsma were all authors on this paper, and Jeff and Aaron have another paper out that's kind of similar, looking just a little further north. They actually went through and inventoried landslides like this. They're coming off the mountains, they're going onto glaciers. They're attractive in terms of scientific study because they make these big dark blotches on top of white glaciers, so they're pretty easy to pick out in satellite imagery. And there are a lot of them in this area. And this is exactly where you might want to go to look for landslides. It's incredibly steep terrain with this right next to the Fairweather Fault. So the rate of uplift is incredible. You know, it's experienced dramatic drawdown of glaciers. So it's exactly the kind of place where you expect to see a lot of landslides, and they do find a lot of landslides here. And they find some substantial trends over time towards larger and more frequent landslides. So this is just an image of kind of some of the densest area there. You can see the giant Lamplugh landslide here from 2016. This is a tens of millions of cubic meters landslide, a huge seismic signal, that sort of thing. You can see all sorts of other landslides. So this is the Lituya landslide, Lituya mountain landslide. There's one here that looks like it was a while ago. It's all distorted by shear in the glacier. Here's a landslide deposit. There's a little one or two over here. So this area is very, very productive as far as landslides. And that's kind of, this is the kind of place where you might expect that. And you can see the really dirty glacier coming down here. Although, you know, you can see up here, these recent landslides have this real characteristic of cutting across the flow lines. And most of this dirt seems to be more related to kind of glacier confluence, the medial moraines formed at glacier confluence. But some of that may well be old landslides. So maybe we're seeing something that's been going on for a long time here. And as Jeff and Aaron note, you know, increasing recently. If we look across Alaska, there are other places where we see these. This is a kind of terrible photo, but I included it because it was, you got to see that some of these aren't beautifully revealed by satellite imagery. And because this one happens to be the closest one to me, this is the Kniknik landslide, which was sometime in late summer 2017. And so this kind of radiating pattern here is a landslide. A small summit just south of here failed, and it spread out across the glacier here. And this is outside of the areas where you'd necessarily expect to see a lot of these. And this was part of what got me wondering, like, how common are these? And I've looked across most of the state now for you know, the really obvious ones. And the ones that are particularly obvious are those that happen below the Fern line. So there's no net accumulation of snow on top of them. And so you get these, they often appear as these terraces because they insulate the ice and they have this steep slope around it. This is the Buckskin Glacier landslide. I found this one Googling online for Alaska landslides. It's really, you know, aesthetically pleasing. And up in the Alaska range where there's lots of flight seeing tourism. So a lot of people have photographed it. This one happened somewhere around 1995. And then there's this one, the Allen Glacier landslide is one of the largest of these below Fern line landslides in Alaska. Thought to probably have happened during the earthquake in 1964 or thereabouts. It was noted after the earthquake. Here's the oldest one that I've really been able to chase down. I was able to find images all the way back to the 50s where this landslide deposit was making its way down Sylvester Glacier on the north side of the Chugach. So if we take and just zoom way out, so there's that Sylvester Glacier landslide there. It's not a very big landslide. It's only a couple million cubic meters. And you can see it's the largest one below Fern line in this huge area. So this is Matanuska Glacier. The Copper Basin is up here, upper Matanuska, so the highway coming up this way. So in this, unlike what we saw down by Johns Hopkins, down by Glacier Bay and Jeff Coe's and Aaron Bessa-Kierten's work, there really aren't very many of these here. And actually the same applies if we go to the south side of the Chugach. And so here's Barry Arm. This is, Anchorage would be just around the corner here. This is Knik Glacier. This is Harvard Glacier. And there is this one landslide deposit, pretty stretched out, but it happened around 1990, kind of small one here. And so, you could say, well, this area doesn't seem to have a lot of this sort of activity going on. But it turns out, actually, recently there has been some of this sort of activity. This is, this won't be quite as pat a story as I might like, because this is the only one that is actually below Fern line. This is what I call Upper Barry Landslide 1, and happened in 2017. So this photo is the next year, so there's snow on it. But you can see it's melting out. So this will be visible every year after snow melt. And what's really interesting here is that Barry has, since this landslide, it has had 5 other landslides. And this is just one of those that are, similar in scale. These are like million cubic meter kind of landslides. They're quite large compared to, what we might commonly encounter. And these are all descending down onto a glacier that's bright white. It doesn't look like it has a history of landslides. And so it makes me think that there probably is an increase in landslide activity in this area, specifically on Barry Glacier especially. There are also a couple other landslides that have happened outside Barry Glacier in that time. Sorry about the background noise. And so I want to go from there to some of the kind of scarier landslides, I guess. So these are the really big ones that are happening, or they're actually instabilities. So actually, it's a little semantics here. I'm referring to landslides as catastrophic landslides. So landslides that are moving, accelerating at a significant percentage of the speed, the acceleration due to gravity. You totally could call this a landslide as well. It's just a slow moving landslide. But we do see in places like Tan Fjord and others that these slow moving landslides can fail catastrophically and can become these fast moving landslides that actually can generate tsunamis and be a direct hazard themselves. And so, so this one is kind of a fun one because you can actually look at, if you use Google Earth's historic imagery tool, you can actually see it moving over the past few years as this tongue of Grand Plateau Glacier retreats. This is down in it's kind of southeast of Yakutat in a really remote area. So in that way, it doesn't pose a lot of hazard, although I walked by on this area on the beach and we kind of scurried past the area that's downstream of this out of concern that this might happen at any time. This might fail at any time. And it was also inspiration for this little block diagram that I worked on with an artist to help explain this kind of system. Here's another one that's sort of in that same area, similar kind of story. It's got this obvious huge scarp along here. This scarp is new since the 80s anyway. So this is an active landslide that could fail catastrophically onto Alsek Glacier. Now these ones, pretty remote. This is one other one that's quite remote. This is in Talkeetna Mountains. A photo taken by Chris Palm. I have yet to get a good satellite image of this instability. You can see in older images of the area that there are a few lineations that maybe suggest instability, but sometime in the last year, it has accelerated and the whole ground surface is just full of fractures. And so this one may well be one that we'll see fail in the next couple of years, or maybe not. Here's another angle on that. But all of these here are quite remote. If they fail, they're, someone, some remote adventurer or hunter or something might be in danger, but they don't directly pose hazards to civilized areas. There are others that do actually pose more of a hazard to people. And this is one that I've been really interested in. This area above Columbia Glacier shows signs of deformation in the past. That's right here. This is a different image. That's this area right here. So just back from the Columbia Glacier face. So boats travel up into here, some of them carrying 150 or so tourists. There's a lot of kayaker activity in here. It's really normal to have a lot of human activity in Columbia Fjord during the summer. And while this, if when this photo was taken, or this, the photos in this mosaic were taken, this failure had happened, it probably would have reached the water and produced a tsunami. It probably would have been a pretty limited one. A lot of the energy would have been dissipated on the glacier. However, since this was taken, the ice has retreated to just short of that instability. Here, I'm going to skip ahead a little bit. And it's actually next year, there should be open water directly underneath that instability. And we do see a pattern of failure happening during the period when a slope is directly debuttressed. So it's quite probable, it's quite plausible anyway, that we'd see catastrophic failure here in the next few years. And part of what we're seeing here is that there are some signs of change on this that suggest motion. So this is a more recent image, and then this is an image from, I think this is 1980s, early 1980s. So one thing you see between these two is that there's this double lake here that drained between this image and that image. Another feature you can see is this light colored line here, which is probably a tension crack that is not visible in this one. So this is one that actually there's several of us, I'm working with Milan Jacquemart and Noah Finnegan. We're trying to figure out a way to get some funding to study this because it's a great scientific subject and also a present concern as far as hazards. Another kind of interesting one that presents some potential concern is the Turner Glacier instability. You can pick out some of the tension cracks and stuff in this area. Basically, this whole section of the mountain is riddled with cracks and scarps. And this area is of concern. So it's right here, south of the word glacier and Turner Glacier, because cruise ships with thousands of people on them come up and hang out right here to view the face of Hubbard Glacier. I noticed this one, I guess it was late summer of 2020, and I was asking around, I heard that Tim Bartholomew, glaciologist, had an active project that was spooling up to study Turner Glacier because it has this pattern of frequent surges. And so I sent him an email, just letting him know about this, asking if there's anything any observations he has. I got his email bounced back because he was actually in the field at this place, and he came back and he saw my email, and then he sent me this photo that he'd taken while installing a seismometer. And so this is an active sinkhole over a tension crack. Seeing all this raw soil and sign of recent sloughing suggests that this although this is probably an old feature, that it has actually been active just recently. So it's a site that's of some concern. I was talking to him recently, and he has a seismic station on here that is hoping will produce some results. So some study going into this, although in a somewhat haphazard way. There are others that aren't being studied at all. This is the Mount Maynard instability. This one is scary because it's directly above Whittier, there's no direct evidence that it's moving, but the deformation features look quite young, so that one's worrisome. This is the Comicia Glacier instability, this area in here. This one has had, this little corner of it has failed recently. There's signs of an older landslide deposit there. Here you can see some of these tension cracks, kind of a conjugate set at almost 90 degrees from each other. That's here. So the concern there is if it were to flow all the way into Valdez Glacier Lake, then the resulting flood and tsunami could impact some of the outskirts of Valdez, including their airport here. And there are places where it's not so much the the tsunami story, this is a giant instability, hundreds of millions of cubic meters, most likely above Sheep River. It's got these recent small failures at its toe that suggest it may well be active. It's far from any people itself, but it could dam the Sheep River. And if that then failed and produced an outburst flood, it's upstream of places like Talkeetna and Trapper Creek. So I want to wrap it up somewhat soon here so that we have a chance to talk. But one of the obvious things to ask is there any correlation between some of these instabilities and landslides and the active faults in Alaska? So this is just overlaying the Quaternary faults database with my database of instabilities and landslides. And there definitely is. There's some areas like this out in the far western Denali Fault, like these here, that are obviously related. So this is on Montague Island. The Patton Bay Fault is right near here, and there's this whole string of instabilities that look like this. One of the things that's distinctive about these is they don't really pay as much attention to topography as instabilities that might be more homegrown. This is related to this very active fault. So the pre-1964 shoreline is here in this area, uplifted dramatically. Similarly, this is way out in the western Denali Fault, and you see all these anti-scarps up this mountainside. So it seems very plausible this is related to activity on that fault. But there are some interesting things, I think, that jump out in here. This cluster of landslides near this minor one is, I think, interesting. And they're really, it's hard for me not to draw a line through this series of points, but there's no known active fault in the area. This is the Berry Arm is at the northeast end of this whole string here. So I think that there may be some things to chew on there. I'm going to go ahead and just call that a stopping point here, and invite you to, I know there's a lot of other things I could have talked about to give more context for that, but I'd rather just have you guys ask questions, and if it seems like a good idea, I'll open up my GIS and we can look at some other things as we go here. So for now, I'll say thank you, and yeah, go ahead and jump in with questions.
All right, thank you, Hig. It was fascinating. I got to learn about, I've never heard of mallards before, so that was, for me, really cool to learn about. Well, for the audience, are there questions or discussion, comments? Oh, Esther.
Yeah. Thanks for the talk. That was awesome. I guess my question would be, have you made a concerted effort to look at areas that are habitated more than not? You showed a few, Whittier, etc., but some of those are really remote and therefore not going to have any sort of human impact. Have you maybe focused a search on areas around villages, etc.? Just curious.
It's somewhat I have, but not excluding more remote areas. And it's my landslide and instability gathering strategy might be somewhat squirrel-like. I kind of follow off whatever catches my attention, and that sometimes leads me in different places. But I do definitely try to spend some extra time around inhabited areas. And also there's often better data in those places. We do have LiDAR near a lot of inhabited places. And so for one example would be in Juneau. There's good LiDAR around there, and I came across a dramatic set of landslide deposits, and then above that is a mountain that has some tension cracks in it, and it's right above the Lemon Creek neighborhood, and so that's actually spawned a little local research effort to look at those, and like Tom Mattis with the city has been really involved there, and a number of others. So those sorts of things, both because of available data and because of, attention spent, I've looked more in inhabited areas.
Thank you.
Oh, Liam, go ahead.
Hi, Hig. Yeah, thanks. That was really cool. I love the really beautiful imagery you showed. It's great to see this overview figure where you're showing the locations of these landslides, and I couldn't help to, as a seismologist, to be tempted, given that some of them are pretty large, greater than 1 billion cubic meters. So I was wondering if you had plans to publish the catalog, or sort of like have it, like what's the deliverable if you're planning that far ahead? Because I'd be super curious to sort of cross-reference this and use it to populate, for example, like the IRIS exotic seismic events catalog. Yeah.
So I think two answers. I do aspire to like properly get this together into publication form, and you can take a look at the database and you'll see there's a column I added recently that's like, I don't know, published category or something like that, where I'm trying to, weed out the ones that are maybe the least systematic and least representative of the approach I'm taking, and really kind of boil it down to something that might be more useful as a publication. However, my top priority is just to make it useful, and I'm really happy to just share the data set with anyone who wants to take a look at it. And I keep it in a Google sheet, and I update it there, and so you can download it, and actually if you download it as a CSV, it's got a lat long column, and so you can directly open it in GIS really easily, which is often how I interact with it. So I would I'd love to feed your curiosity and open that conversation. I think that ones like that, I mentioned that Trail Creek landslide north of the Tikchik, that's one that I'd love to see the seismic signal, because it must have let loose really sharply, because it is so, it's just such an incredibly mobile landslide, and it's big enough that I think it should show up. And there are others too. This recent, the recent one that I noted up on Upper Barry, the one that happened this year was, I don't know if you were involved in like sifting through the seismic catalog, but I know that it was eventually noted.
Right. Cool. That sounds great. Thank you.
All right, we've got a couple more hands up. First, Sean Lehusen, and then Rick Wilson next. Go ahead, Sean.
Hey, awesome talk, really cool imagery, and just a ton of work finding all these slides and mapping them. I guess I just want to get your qualitative take on, whether you've thought about how hazard evolves in time following ice retreat. So, do you notice that maybe there's like a really short window of time where things tend to be really active following that terminus kind of retreating by those ever steepening fjord walls, or does it seem to persist for, I guess, decades or longer?
Yeah, well, that's the $1 billion question there. You can look at, I've thought about it a lot, which doesn't mean I have a good answer for you, but just some pieces of it. I think Lituya Bay is an interesting example, because really rapid glacial retreat happened there probably in the 1600s, and actually the ice probably retreated further than where it is now at that time, and has advanced a little bit since then, although now it's retreating again. But there are these 3 landslides I mentioned that were really big, dramatic, and deadly landslides, and there's at least 1 or 2 prior to that that there's evidence for, and so there was kind of a whole sequence spread out over centuries of these landslides. I think it's also notable, so if you look at Gruink, for instance, there was quite steady retreat, and just as the glacier passed the toe of that landslide, that's when it failed. And the timing was, that's quite a coincidence. I could point to another example that's not widely known, Dorsheen, that is exactly the same kind of thing, and there are probably a few others of those out there. But it's not the story every time, but it happens enough that it's hard to say that's just a coincidence. And then if you look at Ton is one of the most provocative examples out there, I think, because here we have the glacier retreats really dramatically, and around the time that the toe reaches the base of the slope starts deforming, and it moves as a slow-moving landslide, moves many tens of meters over the course of a decade or so, a little less than a decade. And then it seems to stop. I'm sure it probably wasn't completely stopped. If we had INSAR there or something, we would say it was still moving. But it sits there with no real obvious deformation for about 10 years. Then it resumes motion and then fails catastrophically. And And during that time, the glacier was thinning. So there was ongoing debuttressing, but it was much less dramatic than most of the history of debuttressing there. And boy, that's a scary sequence when you take a look at something like the arm, where we saw the acceleration, it's now in this pause. We don't know what it is that causes this transition between creep and kind of catastrophic failure, or just sort of unconstrained deformation. So I mean, we know at some very basic levels, but we can't predict it. And but I think that at some level, there's got to be a significant relationship between glacial retreat and failure.
Yeah. Well, thanks.
All right, Rick, you're next.
Yeah, going off on a somewhat different angle, I wonder if it would be worth taking a look at potential for human-caused landslides on the proposed false pass to, or not false pass, King Cove to Coal Bay Road. There is a short road there now that last time I looked at some Landsat imagery was already closed by slumps. And I just wonder if in putting that road in along the bay that it would actually be inducing landslides.
Mm-hmm. Yeah, it's a good question. That's really, it's definitely getting outside of my, there are many people who could provide a much better answer to that. But I will note that I've spent a fair amount of time looking at imagery down the Alaska Peninsula, and I'm somewhat familiar with the area. And I've been surprised at how few sites with this kind of instability that I found. I would have expected this volcanic landscape to be prone to deep-seated failure. But it hasn't been the story that has come out. And partly the imagery is not as good there in general. It's just so much overcast and there's less focus. There's less kind of the satellites aren't tasked out there as often. But but I've been surprised at how little there was. But yeah, certainly, if you cut a road through a slope, then that increases the probability of failure. And in this world we have we haven't explicitly talked about it, but increasing rainfall events, this applies across the whole state, mean that even slopes that were stable without cutting a road into them are potentially of concern for failure, and cutting a road through it will increase that probability.
I've done a lot of geologic mapping out on the Alaska Peninsula, and there is a particular formation there, the Meshik Formation, which we noticed has lots of slumps in it. They're small slumps, but it has a tendency to let go a lot. So and it's a older volcanic unit that just it almost got to the point where if we flew in and landed on a ridge and you saw Meshik, you just turn to the other person you were with and frown, and that would tell you, oh, you're on Meshik again.
Well, there actually, so that, right in that area, there's one fairly sizable recent landslide. I'm trying to think what the best source of imagery is. It might be visible. A lot of the images that I showed are from Esri way back. This is if you aren't familiar with this site, it's pretty awesome. But there's a quite sizable one, and actually in that area around Meshik, I'm sorry, I'm not thinking of Meshik, I'm thinking of Makushan, sorry. So that's actually a different place, but I'll see if that landslide is just going to jump out at me while I'm going here. Here it is. Yeah, and I mean, my work has been super biased against small landslides, to the point where if I work on publishing that, I'm just going to cut out the smaller stuff, because what I have is so unrepresentative that it's bordering on useless. I do try to record anything I hear about, and so, like, for instance, just a few weeks ago, there was a small landslide onto a glacier that was visible from the town of Seward. And I'll definitely want to have that in my general data set, but I think from a you wouldn't certainly wouldn't want to take the few I've selected and do any statistics on them or anything like that.
Oh, Hig, this is Matt. I just was selfishly interested in that one you just showed. So that's the dots on your map that are out on Unalaska Island.
Yeah.
This
Yep. So that one's just west of Dutch Harbor. There's some really interesting ones over on Actan. The weirdest one there is this valley here. I'm pretty sure this is some sort of landslide deposit, but it is one of the weirder ones that I've seen. I would love to hear anyone who's worked in the field there interpret what it is. It's fairly old. The river's come to equilibrium running through it, but it's got a lot of hallmarks of it being, a highly mobile landslide. But these weird rib features are with the ponds in them. I mean, I would guess it means there was a bunch of ice included in the failure, and these are essentially kettle-like features, but they're really unusual. I don't know of any other example that looks like this. So, but yeah, there are a few out in that area.
All right.
Could what you be looking at there is actually a volcanic debris flow?
Yeah, well, it isn't. I mean, a volcanic debris flow, I would expect, if it was just a classic one, if we're talking either, a lahar or just an explosive debris flow, I would expect it to be more blanket-like than this. These weird transverse ridges with the holes in between, the only way I can think to make that is that you actually have to transport some really big chunks of ice with it. And that would imply, it's not, if you have a really big explosive source, you're going to pulverize that ice. So I don't think you would have these big coherent ice blocks. So I would tend to go more towards like a glacier detachment with a lot of volcanic material entrained along with it. But yeah, really weird. So, you could go a lot of directions probably.
Oh, and Hig, Sean LeHusen has posted a comment or an idea in the chat about that feature on Acatan.
Yeah, no, I thought about about moraines. I mean, it has some similarities, but I don't think so. Like let me see, I'll go back to that image here. So moraines are typically more concentric than this. It would be very unusual to have such prominent moraines in close succession like this, but each one kind of separated and at a different angle like this. So, I mean, I can't rule it out, completely, but it does not look like moraine sequences that I've seen. There's something called Rogan moraines, which I'm only slightly familiar with, but they're beautiful examples of them emerging out from underneath Malaspina Glacier that have some similarity to this, but there's still some big differences too. And if you go upstream, you do see what would look like more conventional landslide deposits in here, still with these lakes marking them, or like, what's this here? These look like stretch features, not like, they're not so much ridges interspersing lakes. They're lakes interspersing like a plateau or, a flat deposit. So, yeah.
Certainly a bizarre landscape.
Yeah, it's a neat one. It'd be like I looked at the geologic mapping and the geologic map didn't have any real insight into it. I don't remember exactly what they categorize it as, but it didn't provide any detailed interpretation of it. But yeah, it'd be fascinating to go out there and look at some of the cut banks along here and see if we could make some sense out of it.
Oh, Dennis.
Hey, Hig, thanks. Great talk. I don't want to take too much of your time because I'll catch up with you in a week or two. But I was curious as to, when you're discovering these things, what proportion are you discovering just through analysis of imagery versus word of mouth or pilot reports, things like that. And then also for the ones that you are discovering by imagery, what are your sources that you're using, those beyond maybe potentially like Google Earth or Digital Globe or Planet or kind of the more obvious stuff? Thanks.
Yeah, so I'd say 90% are ones that I just stumble across myself, but some of the most interesting ones are ones that I hear about from I love that, we have in Alaska this big population of people who go out into wild places, whether they're adventurers or pilots or fishermen or whatever, but are kind of naturalists, they've got sharp eyes and they're looking for these things. And so those are really very interesting ones that come up. As far as imagery sources, the free imagery sources have a big advantage in that they're delivered through these just really nice user-friendly platforms. And so if you're going as wide and shallow as I am, if you're really trying to cover a lot of ground, using Google Earth, or really the most useful one has been that Esri Wayback app that I was just showing there. And part of that is that you can actually pull out multiple images. They have this little timeline tool up here. And so I use this a lot. I do have EVWHS access, which is, Digital Globe and Worldview and such. And then there's the DGGS's elevation portal is such a great way to look at LiDAR data sets. I spend time on there whenever there happens to be a data set available. And really, I've kind of looked at all of those, all of their LiDAR data sets, because it's a big state, but it's in some ways a small state too, as far as good data. And I actually don't currently have Planet access, but it's something I need to work out. I'm getting there, I think. But having all of these is really good. One thing I try to do is I pull out, so like Sentinel-1 or Sentinel-2, actually both Sentinel-1 and Sentinel-2. When Sentinel-2 imagery comes out, if there's a good image, I often will just, like, sometime when my brain's half fried and I can't focus on whatever it is I'm supposed to be doing, I'll go and just browse new imagery. And that's often how I come across the really recent events, like the landslide that happened up for Barry earlier this year. And Sentinel-1, that's radar. I am not an INSAR guy. I've not learned that skill set, but just the reflectance is a very useful way of seeing change. For one thing, it's a great way to pin down the date of failures, because you can often pick them out in Sentinel-1 reflectance. And so I do use that quite a lot. So yeah, anyway, that's really a good one.
Yeah, I was gonna say that I found in my very limited exposure to SAR, like just looking at the amplitudes, especially for the glacier events, like it's amazing, the contrast. And then of course you can see through bad weather, which can be crucial. Yeah.
Yep. Yeah, no, I've been putting together animations, just pulling down, pick same look angle for a Sentinel-1 reflectance, and assembling them into essentially little time-lapse movies. And it's such a rich set of information to look at. There's all this crazy stuff going on with these big outburst floods down in Lituya Bay. That has been, really changed how I understand what's going on there. And you really kind of have to run it together into these sequences. Not that you necessarily play it as a full animation, but you can click through successive frames back and forth and that sort of thing. And there are changes that you wouldn't necessarily pick up as anything unusual just looking at any one of them, but you see the change between them and you can pick out really very, very interesting stuff. And I do also look out my window at Iliamna volcano all the time, and I've been able to see some of those, but not. I've never actually gotten the perfect view of one of those big events. But
all right. Well, any other questions? I was gonna end the formal recording right now, and who knows, maybe that will provoke some other